Hi, I'm Abhigyan Singh, final year computer engineering student, and today I'm going to take you through the journey of my final year project. Being a computer engineering student, I always wanted my final year project to involve some kind of hardware, and then I came across this project. Upon my first interaction with Prof. Douglas, I was very intrigued by this project and hence decided to choose it. For this project, we made use of the lab at KVI Private Limited. This lab was equipped with all the machines that we needed for testing out our NLV code, including the current and voltage regulators responsible for charging the batteries, as well as the temperature sensors which were needed to monitor the temperature of the batteries while charging. Initially, we tried to incorporate all the changes we wanted into the existing code base, but it was soon found that it wasn't the best practice to do so because the existing code base did not follow any software engineering principles, there were no comments, and gave inconsistent results. And hence, I started developing a fresh code base for our NLV algorithm. First, let us talk about how NLV actually works. NLV increases the voltage in a stepwise manner rather than a constant voltage or a constant increase. So as soon as the current goes below the Imin specified by the user, the voltage increase is increased by one step of delta V, and this delta V is also input by the user. This process continues until the termination NLV voltage is reached, and this termination voltage can also be manually input by the user himself. Let us look at some of the features of NLV. So, as you can see in this graph, the graph is a non-linear graph, and we are able to control the voltage and not let it go above 4.3, which is the maximum limit specified by many lithium-ion battery manufacturers. We are able to put in high currents into the battery because we provide a short rest pulse after every high current pulse, and we are able to significantly reduce the charging time, as we were able to charge 90% of the battery in just 20 minutes. For this project, we performed a number of tests. Let me share a brief summary of the tests with you. So first, we tried to find out the correct NLV parameters for charging of a 30T cell. And we began this by looking at different delta V values while charging the 30T cell for 24 minutes. And we used 85, 90, 95, and 100 millivolts to perform these tests. And some of the results we got showed that actually using 90 millivolts as the delta V is the best parameter for NLV. Then we also performed some tests to find out the optimal termination voltage for NLV and found that 4.3 was actually the best termination voltage for NLV. Then we even tried to experiment and find out which Imin value would be good for NLV, and we found that 7.5 would be good when charging a 30T cell for 20 minutes. Apart from this, we also developed a program that performs CCCV, which is constant current, constant voltage, on 30T cells. And here are some of the results produced by our program. Now, at the end, we wanted to make sure that when we charge using NLV, it does not cause a degradation in the battery capacity, and hence we performed 125 NLV cycles. At the end of all these NLV cycles, we tried to perform one CCCV cycle, and this CCCV cycle, as seen here, ran for 117 minutes, which is 98% capacity, which showed that after running 125 NLV cycles on one cell, there was no reduction in the battery capacity, which proves that NLV does not cause a reduction in battery capacity. Apart from this, we also ran a GITT test. GITT is a common electrochemical test which helps us to see the difference between the OCV while charging, at rest, and while discharging. These were the algorithms that we used for the GITT testing. We used the Chentech machines which are available at KVI laboratories, and here are the results from these tests. We can clearly see that there is a bridge or a gap between the charging OCV and the rest OCV. And same for while discharging, we can see that the discharge OCV and the rest OCV, there is a gap between. This project has given me a great insight into how batteries are charged, and also allowed me to apply the various software engineering principles that I learned throughout my degree. I would also like to thank Prof. Douglas for his constant support and constant encouragement throughout this project. Thank you.